This morning I ran across a bit of syntax in Bash that I thought was kind of interesting, so I wanted to show that off here a little bit. Might be helpful for some situations. The feature in Bash that I'm talking about is called Pseudo-Device files. So just to demonstrate it, I'm going to create a netcat server over here, just listening on localhost 12345. So over here in my client terminal, if I do like echo foobar into, just redirect that to dev TCP localhost 12345. So this dev TCP is a pseudo-device file. So when I run that, it actually creates the socket to the server and wires it up as the file descriptor for that socket as the standard out file descriptor for the command echo. And echo performed its writes, and then when echo closes or exits, it closes all of its file descriptors, including the one to the server, which closes the connection to the server here. So you can do that. You can also do the inverse of it. So you can say like cat, and I'm going to cat, this way, redirect to the standard in of cat, the same path. In this case, say connection refused because I don't have the server open here. So let me just do that now. Rerun that. And when I type over, when the server starts writing over here, so I say hello from the server, those writes then go down to the client here. And since the server is holding open the connection, so does the client. And then when the server closes the connection, that'll close the connection on the client side as well. You can do this with UDP as well. So if I just do echo foobar over UDP, do -u over here, it works very similar. So you can, wire up a TCP or UDP server as either your standard in, standard out, or standard error for your pipelines in shell. And so I was like curious, I was like, well, how's this dev UDP thing, how's that implemented? So if you do ls-la on device and grep for UDP or TCP, there's nothing in the device directory for those two things. And that's because these aren't actually files. They're not virtual file systems. They're not paths that are actually on the file system. It is a pseudo-device file, which is kind of odd because I've seen some weird syntax in Bash and Shell for doing odd features, but this one kind of simulates that it's an actual file on the file system or directory on the file system, and it's not. So it's kind of strange. I've never seen that before. So yeah, you can send data to, receive data from. And then another thing you can do is instead of wiring the file descriptor as standard in or standard out of a pipeline, you can actually assign it to an arbitrary file descriptor. So if you do an exec3, this is a bit of a weird syntax, but the way I interpret this syntax is 3 is the file descriptor, similar to like if you're doing redirection, like say I do echo 2 to, or say echo foobar, and send 2 to dev, or let's say 1 to dev null, and you could do 2, I'm sure you've seen this syntax before, and 1. So that says like take file descriptor 2 and send it to file descriptor 1. There's a lot of different bits of syntax that are around redirection and assigning of file descriptors. So if you do an exec3, this syntax I read as both basically set up like a bidirectional stream to this pseudo-device file. So we're going to do that to TCP localhost 12345. Let me run the server in TCP mode over here. So what this does, I'm not going to run it right now, but what it'll do is it will establish that socket. The socket will then return like a file descriptor. That file descriptor gets assigned to the file descriptor number 3. So it's not standard in, it's not standard out, it's not standard error, which are 0, 1, and 2. it's a new file descriptor, an arbitrary one. So we go ahead and do that, and because we exec it, instead, like all of these things are setting the file descriptors for processes that are child processes. Like echo is not the shell. Echo is a child process of the shell. Same thing with grep, all these commands. But when you exec, you're actually running this in the shell itself. So it's saying like in the shell, its file descriptor 3 is going to be this socket. So we'll go ahead and do that. And then we can just say printf, and we'll just do some HTTP 1.1 here. And we'll just get the root path of localhost. Actually, you know what? I'm going to go back here and I'm going to say instead of localhost, let's do like a real web server. Let's do google.com. I think that'd be a better example. And we'll do port 80. Printf get /http /1.1. Some carriage return line feed stuff, and then we'll say, okay, instead of sending that to standard out, we're going to send that to file descriptor 3. So that sent the request to Google, and then we can just cat from that file descriptor, and that reads the response from Google. And this is a persistent connection to the Google server. Until this bash process exits, that file descriptor will remain open. Unless it times out or something, the server can reset at any point. But I thought that was pretty cool. Not only that you can create these arbitrary file descriptors, which I kind of knew about, but that there's these set of pseudo-device files that allow you to create sockets. Yeah, wild stuff. Anyways, just wanted to share that.